Way to do it.
Yeah, we definitely trust your judgment there.
You want that D-ring instead? Yeah, sure. We just got to make sure we've got a good spot for a ret. We do. On the white tape there. We just got to make sure we've got a good spot for a ret. We do. On the white tape there. We just got to make sure. I think we did it. Yeah. It's about thirds. It's an ugly thirds, but it's thirds. No, look, that's all the metal. So yeah. Okay. All right. So we are in good shape.
Really nice work, guys.
All right. Can I ask you a favor? In good shape. Can I have you put this on? All right. So I'll put it wherever you want it. On the far stanchion there? On the handrail? Yeah. Okay, let's make sure we're good on crossing any tethers here. Like, you can let it go. Yeah, you're going to have to go over first. Never mind. Yep. Go for it. Once you want me to go to the APFR? Yeah. Give me one. My tether's still good, and it's on top. At least deconflicted with you. My tether's still good. My tether's still good, and it's on top. Deconflicted with you. At least deconflicted with you. My tether's still good. Clear. Thanks. If this pitch is so hard to move, can we leave it in, like pop up, pop up?
Yeah, Josh, we're good with that.
Okay, so need anything in terms of reconfig here?
Negative. That's fine, Josh.
Good afternoon and welcome to NASA's Kennedy Space Center in Florida for live coverage of the tanking of the Space Launch System, NASA's 32-story tall moon rocket that you see there at the center of your screen. We're tanking it ahead of our third Artemis I launch attempt. I'm Daryl Nail, and I'm glad to be with you on this 15th day in November, coming to you from inside Firing Room 1 at the historic Launch Control Center here in Florida. We have close to 93 launch system engineers in Firing Room 1 with Exploration Ground Systems. They are configuring the core stage at this moment, along with the upper stage, for cryogenic tanking, which is essentially the super chilled fueling of the largest rocket booster stage in the world. Launch is on November 16th, tomorrow, the early hours of the 16th at 1:04 a.m. Eastern Time. We have a 2-hour window, if needed, that runs until 3:04 a.m. Eastern Time. I want to get you caught up on everything that is happening. We have just gotten a go from Charlie Blackwell Thompson at 3:27 p.m. Eastern Time. She gave the, 3:22 p.m. Eastern Time. She gave the go for cryogenic tanking. And at 3:27 p.m. Eastern Time, the core stage circulation pumps and heaters were activated. The team is currently configuring the rocket for tanking. Charlie Blackwell Thompson telling her team before she gave the go that it's taken a ton of work to get here, a lot of grit and determination, and then urged them to get this rocket tanked and into terminal count. Now, just about a half hour ago, we had a mission management team meeting, which is part of the protocol before launch, chaired by Mike Seraphin. It was a good meeting, only 14 minutes long. In fact, the shortest I've been a part of, going back to the first wet dress rehearsal. Charlie Blackwell Thompson came to the meeting saying, for the first time ever, we will have a clean board going into the meeting. Of course, she then knocked on the wood table, and as did the rest of the mission management team. Things are looking good. Spirits are high. I talked to several members of the launch team. Confidence is high. Folks are feeling good about the launch opportunity today. Now, we had a final walk down at 1:34 p.m. Eastern Time of the pad that you see there, looking for any foreign object debris, anything that shouldn't be there that could fly around once launch happens. Then they cleared out the blast danger area, prepared the liquid hydrogen and liquid oxygen tanks, the giant cryospheres, which will fill the rocket with propellant. And then we got a weather update from Launch Weather Officer Mark Berger with the 45th Space Wing. He said that we look absolutely fantastic for tanking. You do see the clouds in the sky overhead. We do have a little bit of cloud cover and the roughly about the 20,000 foot level, but conditions are calm. And so there are no constraints to tanking, 0% chance of lightning within 5 nautical miles. But the LWO did say we could get some sprinkles around 8 p.m., if not a little sooner. There are some lightning and storms off the west coast of Florida in the Gulf, and they do have some cloud, so a thicker cloud deck coming over the state at this point in time, but LWO says that it doesn't look like it's going to constrain tanking. When we get into launch, the go for launch weather has been reduced to 80%, down from 90%, which is still excellent. It's the best weather forecast we've had since we've started the launch campaign. And again, the only fly in the ointment is the clouds. Tracking some of that imagery in the storms off western Florida. The only areas of concern once we get into the launch countdown will be the thick cloud layer rule and the cumulus cloud rule. thick cloud layer rule because of the possibility that the rocket could be affected by that water in the atmosphere, and then the cumulus cloud rule. If we were launching right now, the LWO did say that we could launch right through the clouds that you see there. Hopefully we get some clearing, because if you're in the area of Florida or South Georgia, well, those clouds could obscure the view. So hopefully we'll get them cleared out. I'll be listening to the launch team as they give their call-outs over the nets. We call them loops. They are audio communications channels between the various teams that are supporting the launch today. Of course, Exploration Ground Systems here at Kennedy Space Center. We have teams from the Johnson Space Center here supporting Orion. And of course, we have engineers from Marshall Space Flight Center supporting the Space Launch System down from beautiful Huntsville, Alabama. We want to tell you a little bit about the Artemis program as we go along today. If you don't know, NASA is sending astronauts to explore deep space, starting with the moon and then on to Mars, and that's what this rocket here is all about. Here's an introduction to NASA's Artemis program.
NASA is returning to the moon, pushing the boundaries of space exploration, science, and technology once again. We're on the verge of exploring more of the moon than ever before. We're going to learn how to live and work on other worlds for economic benefit and to inspire a new generation, the Artemis generation. With Artemis missions, NASA will land the first woman and first person of color on the moon. We will collaborate with our commercial and international partners and establish the first long-term presence on the moon. We go together for all humanity. Artemis I, the first integrated flight test of the Space Launch System, or SLS rocket, and Orion spacecraft will launch from the historic launch pad 39B at NASA's Kennedy Space Center. It will be the first in a series of increasingly complex missions, paving the way for astronauts to explore the lunar surface and to later use what they learn on the moon to explore Mars.
In just a few minutes, we will begin the operation for cryogenic tanking of the Space Launch System. If you want to learn more about the Artemis I program, just go to our website at nasa.gov/Artemis-1. And we just got the go for liquid oxygen loading operations. Again, we just got the go for loading the liquid oxygen into the core stage. Now, coming up in just a bit, they're going to start the loading operations of the liquid oxygen by chilling down the transfer lines. These are the lines that run so super chilled, they must pre-chill the lines. And I just heard them give the go for core stage liquid hydrogen loading operations. So we've got the goes on both. The liquid hydrogen and liquid oxygen tanks there in the center of the rocket, the core stage, the largest such tanks in the world. That liquid hydrogen is coming in at minus 297 degrees Fahrenheit. On the hydrogen side, it is minus 423 degrees Fahrenheit. And so the team pre-chills the lines by opening up the valves and allowing a little bit of the liquid oxygen to flow in, not much. But that propellant that does go into those lines that run all the way to the mobile launcher, which then feeds it into the rocket through the tail service mast umbilical at the bottom. That cold gas, the liquid flashes off so quickly once it hits the ambient air. The cold gas is then enough to chill down the lines so that when the actual super chilled propellant goes through, it's not a thermal shock to the system. Also new for this countdown, we are loading liquid oxygen and hydrogen at the same time. This is part of a change in the loading procedure for liquid hydrogen, what they've come to call a kinder, gentler operation. Previous launch attempts, we had some hydrogen leaks that the team believes the thermal shock could have played a role. And so the liquid hydrogen operation was lengthened, and they will be flowing that very slowly, allowing just a little bit of pressure on the cryosphere to push that liquid hydrogen into the rocket. Now, unlike the liquid oxygen will be pumped. Liquid hydrogen will flow naturally, just using the pressure that's already in the cryosphere to flow it. LOX is 12 pounds per gallon density, so it's quite heavy. Liquid hydrogen is 0.4 pounds per gallon, so it's extremely light. We will start up our clock here in a couple of hours. Currently, we are L minus 9 hours and 11 minutes until liftoff. Our cryogenic operations will run roughly about 6 hours. This is Artemis Launch Control. A programming note, if you were watching NASA TV's coverage of our EVA, extravehicular activity, it is continuing in the final stages now. That spacewalk you can watch on NASA's media channel. Again, it continues the final stages of our EVA on the International Space Station on our media channel. And we have chill down of the liquid oxygen and liquid hydrogen transfer lines. Again, we have chill down of the liquid oxygen and liquid hydrogen transfer lines that carry the propellant from the cryosphere, both cryospheres, to the rocket. And we have completion of the liquid oxygen transfer line chill down. Again, LOX chill down is complete. Liquid hydrogen chill down still in progress. As we prepare to tank 750,000 gallons of propellant into that rocket right there, the Space Launch System. It will take roughly 6 hours to complete. The team will then have a few hours to make final configurations. We'll get into terminal count. And ahead of that, a programming note, at 10:30 p.m. Eastern Time, we will begin our special launch broadcast here on NASA TV. At the same time, we will continue our operational commentary on the NASA media channel. You can find both of them on YouTube. And of course, NASA TV, where if your local programming and cable company or satellite company provides. And we have a start of the core stage system chill down. minus 8 hours, 49 minutes, and counting until liftoff of Artemis I, the Space Launch System, and Orion spacecraft. We're bringing you live tanking coverage here from the Kennedy Space Center in Florida. You're looking at the rocket, NASA's 32-foot-tall moon rocket, which is in the midst of cryogenic tanking. We got the go to begin loading the rocket with super chilled propellants at 3:22 p.m. Eastern Time. And the team is in the middle of chilling down the lines from the liquid hydrogen cryosphere and the rocket. They have completed that on the liquid oxygen side and now are looking to begin chilling down the main propulsion system. It'll take roughly 6 hours to complete this process. After which, the team will have several hours to finish configuration of the rocket. And then we'll go into terminal count at 12:54 a.m. Eastern Time on November 16th. Liftoff is scheduled for 1:04 a.m. Eastern Time. We have a 2-hour window today. Hopefully we won't need it. Weather officer says we're looking good weather-wise, though you do see on your screen there, get a large cloud deck across the spaceport. A couple holes in it here and there. That cloud cover, it's rather thin where we are here at the Kennedy Space Center, but off to the west, the launch weather officer is tracking some thicker clouds coming our way. It's not a constraint to tanking. We're moving ahead, moving forward, but it is something they're keeping an eye on as we get deeper into the night. This is Artemis Launch Control. update on the LH2 transfer line chill down. We have another 5 minutes in chilling down those lines that run between the LH2 cryosphere, liquid hydrogen, and the rocket. The tank on the core stage holds 537,000 gallons of liquid hydrogen. The loading operation today represents what the launch team calls a kinder, gentler loading operation. They're starting the pressure on the storage tank quite low, closing skid valves, which are on the upper part of the rocket, and then reducing that main fill valve and allow those skid and lines to chill down until the inlet temps are fully chilled before they start running propellant through there. So gravity flow will be the way that they'll move that liquid hydrogen for 4 minutes and then allow the gas to chill down the entire system. Again, just a few minutes left in that. Liquid oxygen transfer lines are complete. And we're going to get into, after that, slow fill, where we actually start to run propellant into the rocket. Slow fill for both the core stage and the liquid core stage liquid hydrogen and oxygen is roughly 500 or so gallons per minute. We're waiting the next milestones. We'll let you know as soon as they happen. This is Artemis Launch Control. We're currently L-minus 8 hours and 32 minutes until liftoff of Artemis I. Stand by. And we just got an update that the liquid hydrogen transfer line chill down is complete and slow fill has begun. Again, liquid hydrogen slow fill has begun. This bumps up the speed of the pumping on the liquid hydrogen side. Meanwhile, on the liquid oxygen side, they are currently in a chill down of the main propulsion system. They put in a little bit of liquid oxygen propellant into the system and then drained it back and allowed the gas to cool down the system. That super cold oxygen. Continuing to track the milestones as we start the liquid hydrogen side. Filling the tanks on the Space Launch System. This is a major milestone. Launch team watching, of course, the liquid hydrogen process closely. A programming note for you on our NASA media channel. It's a busy day here at NASA, both on the ground and in space. The EVA, extravehicular activity, ended at 7 hours and 11 minutes. This is the spacewalk going on at the that happened at the International Space Station. Coverage continues on NASA's media channel. Team just repeating the announcement that they are in LH2 slow fill. But again, the spacewalk coverage continues as they now head into the repress of the airlock and getting the crew back inside with helmets doffed. Again, you can find that on NASA's media channel. Here on NASA's main channel, we continue with the cryogenic tanking of the Space Launch System. It's a great day in Florida for tanking. Weather is not a factor at the moment, even though we have some cloud cover overhead. It was quite a process to get, it always is a complex process to get the rocket to the pad, getting SLS and Orion to the pad, and it all begins with rollout.
Of the 322-foot tall Artemis I rocket from the vehicle assembly building signals launch is approaching. The crawler transporter will travel along the crawlerway to the launch pad, carrying the SLS rocket, Orion spacecraft, and the mobile launcher. After traveling more than 4 miles, the crawler rolls the rocket and spacecraft onto the pad in position over the flame trench. Once in position, the mobile launcher is lowered onto support posts, and the crawler rolls away to a safe distance. 4 mighty core stage RS-25 engines prepare to start as cryogenic propellant flows to the engines. The complex physics of rocketry are about to be put on full display. At T-minus 15 seconds, the sound suppression system releases 400,000 gallons of water, flooding the mobile launcher and flame trench in less than 30 seconds. At T-0, the umbilicals in place to provide power, communications, coolant, and fuel to the rocket and Orion spacecraft, while at the launch pad, retract.
For more information on the Artemis program, just go to our website, nasa.gov/Artemis-1. Again, nasa.gov/Artemis-1. We have an update in the cryogenic tanking. We are now in slow fill for liquid oxygen. Again, we are now in slow fill for liquid oxygen and liquid hydrogen. Teams go about slowly filling the tank so as to prevent thermal shock to the rocket systems. It's a great shot of the mid-level of the rocket there, and the launch vehicle stage the adapter between the core stage and the ICPS. Slow fill for the core stage runs about 40 minutes or so. Sorry, check that. It runs 15 minutes. Again, the core stage liquid oxygen slow fill runs about 15 minutes. Core stage liquid hydrogen slow fill, this will be a longer process. Roughly about 70 minutes, a little more than an hour. And then we get into fast fill. But again, we're getting propellants into both tanks on the core stage. This is Artemis Launch Control. Now we have an update of our milestone, the slow fill portion of the liquid oxygen transfer from the cryosphere that you see off in the distance there to the right-hand, lower right-hand part of the screen. You can see one of the cryospheres is now in fast fill. Again, liquid oxygen going into the rocket is now in fast fill as of 2 minutes ago, completing the slow fill portion of liquid oxygen into the core stage. And there you see one of the aft struts, which actually comes into play with regards to the liquid oxygen flowing in. That strut that you just saw, there's an aft strut constraint that requires that there be 50% filled liquid oxygen in the core stage tank, that they hold it at 50% rather, until they have at least 5% liquid hydrogen over on the hydrogen side. So the propellants are carefully sequenced. There's a shot of it again. That's the aft strut. It connects the solid rocket boosters to the core stage, a very critical component of the Space Launch System. The rocket actually shrinks as these super chilled propellants go into it. And so there's motion there, very, very small amounts of motion. But in order to keep everything aligned and in good shape structurally, liquid oxygen won't go above 50% until we have, again, at least 5% liquid hydrogen in that tank. And so now that we are in fast fill for liquid oxygen, which is roughly double that of slow fill, a little more than double, we're going to be moving pretty quickly on the tanking of the liquid oxygen tank. And there you can see a shot of the core stage engines and the two solid rocket boosters to either side. 4 nozzles in all. 3 of them you can see. One of them is obscured by the engine in the front, right? This is the business end of the rocket. And an engineer is currently controlling that camera as they complete inspections throughout the process of countdown. There are more than 100 cameras trained on this rocket in various areas of the rocket, making sure that they have eyes on all of it as we proceed through the countdown. A note on the sensors, if you're wondering about going from slow fill to fast fill and how it detects where we are, similar to your car, your vehicle. If you have a gauge there that will tell you when it's empty, same thing exists on the core stage, which triggers a shutdown in flight once it reaches empty. The sensors inside the tank, they detect when certain levels are reached, and you want to slow the flow down as they are in fast fill. You want to slow it down to prevent burping of this liquid propellant out of the top, which would be a very bad thing. So you have cutoff sensors, which tell you when it's close to E, basically on your gas gauge. You have the 0 to 5% sensor, which is slow fill. And then there's a sensor that goes from 5% to 95%, and that is the sensor for fast fill. Once it gets up to the top, 95%, there's a sensor from 95% to 100%, and that puts the tanking into a topping, which is about half as fast as fast fill. So they slow it down as it gets up and fills up. And then there's 3 100% sensors, a 100 minus, a 100 even, and a 100 plus. And then that's when we get into replenish. There's software that cycles the valves to keep it in that sweet spot, 100 minus, 100, and 100 plus. And then, of course, replenish just replaces the propellant that boils off. These propellants, the moment they go into the tank, they are boiling. And they will continue boiling all the way through liftoff and during flight. They will be vented initially. That vent will be capped off to build up flight pressures. And then, of course, at the end, when the engines are lit, and this rocket is, if all things go well, racing into space at 1:04 a.m. Eastern Time tomorrow. We're currently 8 hours and 7 minutes until liftoff. This is Artemis Launch Control. got a couple of notable milestones that are coming up in the cryogenic tanking of the Space Launch System. One that has just happened is the aft strut constraint has been verified. So we are over 5% hydrogen filled. And since we're in slow fill, we're now going to transition to fast fill. And this has been a moment in past tankings where we've seen leaks. But today, the team is executing the kinder, gentler, as they call it, loading operation. It's a much slower, very methodical fueling, tanking of the liquid hydrogen tank. And so we'll let you know as soon as that milestone happens. After that, we will then have the liquid hydrogen engine bleed kickstart. The kickstart is essentially a bleed to get it going. They close the vent temporarily. The liquid hydrogen tank is vented. Since it is a liquefied gas, it's boiling off. It vents out the gas. They'll close that vent to pressurize the tank, and then a small amount of liquid hydrogen is bled through the engine, and that gets it going. And then after kickstart, they go to a vented bleed, but at a lower pressure. So they'll open back up the vent, and the bleed will run. And that bleed needs to run through the engines in order to properly condition it for launch. Needs to be in just the right temperatures, which match the propellants. So all those milestones coming up in a bit, and we'll certainly let you know as they happen. And a programming note, coverage of the EVA on NASA's media channel has completed. You are now watching coverage of Artemis I's tanking, the tanking of the Space Launch System and Orion and launch of the Orion spacecraft. Tonight at 1:04 a.m. Eastern Time from the east coast of Florida. We are headed to sunset, as you can see from this shot here, in roughly about 23 minutes. Got some cloud cover overhead as we count down, currently at 7 hours, 56 minutes and counting until liftoff. We started our day here on NASA TV with the tanking go that we received from Launch Director Charlie Blackwell Thompson at 3:22 p.m. Eastern Time. And we are currently flowing propellants on both the liquid oxygen and liquid hydrogen tanks of the Space Launch System. This is involves two steps here. We'll get the lower tanks filled, the largest tanks, and then we'll fill the tanks of the upper stage. Okay, and I'm hearing in real time, we are now transitioning from core stage LH2 slow fill to fast fill. So core stage LH2 is now in fast fill. The propellant teams closely monitoring the data. So we have both tanks now in fast fill. The liquid hydrogen tank holds 537,000 gallons of liquid hydrogen. The liquid oxygen tank, close to 200,000. another big milestone coming up here. The engine bleed kickstart on the liquid hydrogen side is proceeding. Again, the engine bleed kickstart on the liquid hydrogen side of the core stage is now beginning. Again, this kickstart is a pressurized bleed to get it going, get it moving. Close the vent to pressurize the tank, and then a small amount of liquid hydrogen is bled through the engines there that you see at the bottom of the core stage. And then that hydrogen that's bled out is then taken out to a flare stack that burns it off. And with that wide shot, you can see we're getting close to sunset here on the east coast of Florida. In just about 7 minutes. And so far, so good. We are at L-minus 7 hours, 36 minutes and counting until liftoff of the Space Launch System and the Orion spacecraft here from the east coast of Florida, the Kennedy Space Center. I'm joined now by Jeremy Graber, the Assistant Launch Director for the Artemis program. Jeremy, thanks for being here. Appreciate it.
Thanks, Daryl. Happy to be here.
So, the countdown, we're just a few hours into it, and so far, it seems awfully smooth. What's your take?
So, we're doing really well right now. We're in the middle of our tanking operations. We picked up with those tanking operations just a few hours ago. Our launch director, Charlie Blackwell-Thompson, said some great words to our team, and they're actively loading cryogenic fuel into the core stage. So far, everything is going very smoothly, and we're about 25 minutes from coming out of our hold at T-minus 6 hours and 40 minutes. And we've got about an hour and a half of liquid hydrogen fast fill to go, and about 2.5 hours of liquid oxygen fast fill to go. Our teams are monitoring the progress of that loading, doing a great job, and things look really good right now.
The team seemed upbeat when I was at the MMT meeting. A lot of positive vibes all the way around. Charlie Blackwell-Thompson, launch director, didn't have a constraint when she walked into the room. And then, as you mentioned, things have been going pretty well. Now that we're in tanking, this is an area that we have seen issues in the past. The fast fill for liquid hydrogen, especially when we get into the bleed. We're currently in that kickstart bleed, but so far, so good. And there's a different loading operation that was used for this time.
Yeah, this team has done a fantastic job working through each of the different wet dress rehearsals and launch attempts. In addition, we did a tanking test that demonstrated a lot of updated procedures to deal with the challenges that we had seen previously. And this team has really been outstanding, finding the right sequencing, the right, basically keeping everything in a very tight box to ensure that we manage through any potential issues. And so far, everything that they've put in place has been going extremely well. And we'll just keep monitoring as we go.
Yeah, this is as close to the countdown as you lay it out on your bar chart, as they called, that I've seen through 4 wet dresses and 2 launch attempts, and this, of course, being the 3rd.
Absolutely, we are right on the timeline, which is, as a launch guy, that's where I want to be, right on the timeline.
That's right. Had to deal with a hurricane. Had to deal with 2. Obviously, the rocket was inside the VAB for 1, and for the 2nd, it was out there for tropical Hurricane Nicole, rather. So far to this point, have you noticed anything that you would attribute to the hurricane?
Well, so one of the really key things that we've been doing since Nicole passed through is to really investigate and look at all of our systems from a powered up perspective, as well as from an outside visual perspective. And we've been doing that from the minute we were able to really see that. We monitored all of our capabilities on the flight hardware and the ground systems throughout the storm, and we've been keeping a very close eye on everything since the storm made it through. And so far, we've worked through any of the items that we found. I know some of those things have been talked about at the mission management meetings over the last couple of days. We came in to call the stations for launch countdown. We had some work that we carried in. We've made it through all of that work yesterday, and we really have a clear constraints board at this point. Have not seen any issues associated with normal issues that may have come up or from anything else. So, as I said, clear constraints right now and on the timeline.
That's one tough rocket out there, as come to find out. You mentioned the couple of issues that were dealt at the MMT meeting, some of the RTV that came off the seal below Orion, and then along with a connector that was in the same location as a previous hydrogen leak. But you've got redundancy there, so you're good to go, and and it looks like that is not going to be an issue as we proceed forward. We're headed to sunset. As you can see, sun just went down here at the Kennedy Space Center as the lights are on and illuminating the Space Launch System rocket. Getting an update. Engine stand by. So, Jeremy, we just heard from the NASA, from the liquid hydrogen team on the NASA test director's loop. They're reporting out right now. The engine bleed is complete. They did see a little bit of hydrogen in the area, a little bit of leakage, a little over 4%, but that apparently went down. That's within your range, right?
Absolutely, that's it. Within our range, that's you know, an expected leakage rate at that location. And yeah, as you mentioned, the great thing is wherever it got to at that 4%. Since I'm not looking at data right now, I'm
Sure.
kind of, but the good thing is it started coming down as they completed the bleed. So that's exactly what we would expect to see. And based on that, it sounds like we're still doing great.
That seal and that quick disconnect, it has to conform, right, to that space there. And when you hit it with those cryos, that's kind of part of it, right? Just like you were saying. It's
Yep.
kind of
And our
expected.
expectation through the rest of loading is that leakage rate will come down. And that's really what we saw during the tanking test that we performed after the last launch attempt. And so we really do expect to see that leakage come down as we load the core stage tank, the liquid hydrogen tank, and you get more commodity on board. That will really help seal that, and we should see that come down.
All right, great news. Real-time update from our Assistant Launch Director, Jeremy Graver. I really appreciate that. Thank you very much for being here, and good luck to you and the team the rest of the way.
Thanks, Daryl. Appreciate it.
All right, we are at L-7 hours, 28 minutes, and counting until liftoff. This is Artemis Launch Control. This is Artemis Launch Control. We are currently L-minus 7 hours and 18 minutes until liftoff with a beautiful nighttime shot just a few minutes after sunset here on the east coast of Florida. There it is, the Space Launch System rocket illuminated against the night sky. We are currently in the middle of cryogenic tanking of the Space Launch System rocket. Its two largest tanks, liquid hydrogen and liquid oxygen. On this particular shot, I want to draw your attention to the far right-hand side of the screen. You can see the flame there. That is a hydrogen flare stack. That is part of the operation. That hydrogen flare stack takes the engine bleed, the hydrogen, the liquid hydrogen that is run through the engines, the RS-25 engines at the bottom of the rocket, to condition it for launch, get it ready at the right temperatures to light. After it runs through the engine, it then goes out to a flare stack, and there you see it burning. We are currently in a vented bleed configuration for liquid hydrogen, and we will stay in that until inside of terminal count. So this view will be with us for the duration. And just a note, the liquid hydrogen, it is burning, but it's not giving the flames the color. That's actually the impurities that get drawn in along the way, and they give the color, the orangish color of the flame. Now we have an update in terms of the tanking progress so far. We are tracking that with a real-time graphic that is taking data from both of the tanks of the core stage. This visual will allow you to see our progress. On the core stage liquid oxygen, on the left you can see we are at 35% full, currently in fast fill. And over on the right, the core stage liquid hydrogen, the largest tank towards the bottom of the rocket, 40% filled. You can see the capacities, close to 200,000 gallons for liquid oxygen and 538,000 gallons for liquid hydrogen. We've got about a couple hours left to fill the liquid oxygen as it fills at a slower rate during fast fill. Across the bottom of the bar, you can see our progress as we head to the tanking of the upper stage. But again, just about a couple of hours left to tank the liquid oxygen and just about an hour left on the core stage liquid hydrogen, as that one will fill faster than the LOX. We have about 5 minutes left in a pre-planned hold. And after that, we're going to put up our countdown clock so that you can see it. The hold time was roughly about 3.5 hours long, an extended hold. That's part of the longer operation to tank the liquid hydrogen side of the rocket. Our T0 for our launch today is at 1:04 a.m. Eastern Time. We have a special launch broadcast that will start at 10:30 p.m. Eastern Time. And that will happen right here on NASA's main channel. Operational commentary, which you're watching right now, will continue on NASA's media channel. You can find both of them on YouTube. We have a 2-hour launch window tonight, which the launch team likes having a long launch window just in case they run into some weather. But the launch weather officer has reported that we're 80% go for launch weather. It's not expecting to run into that tonight, and hopefully that holds. Throughout the night, we've been sharing the various stages of the Artemis I mission with you. And with just about 7 hours and 12 minutes left in the countdown, we want to take a look at the big moment, liftoff, and what you can expect to see on the Space Launch System and Orion.
During liftoff and ascent, SLS produces 8.8 million pounds of thrust to accelerate the rocket that weighs nearly 6 million pounds towards orbit. Approximately 2 minutes into the mission, the boosters will have consumed all of their solid propellant and are safely released. The rocket continues to propel toward orbit. After 3 minutes, Orion's service module fairings are jettisoned to lighten the load and expose its solar arrays, having completed their job protecting the arrays from aerodynamic forces. 40 seconds later, the launch abort system is jettisoned. Orion could safely abort at any time. About 8 minutes after launch, the SLS core stage engines shut down, and the stage separates. The interim cryogenic propulsion stage, or ICPS, will give Orion the big push it needs to leave Earth's orbit and head toward the Moon. Orion's 4 solar arrays deploy to convert the sun's energy into electricity to power the spacecraft, charging its batteries for power when it moves out of direct sunlight. The upper stage engine ignites to elevate the spacecraft and fully enter Earth orbit, targeting conditions for the maneuver that will send Orion to the Moon. Engineers at Mission Control in Houston will perform one last check on Orion systems prior to committing to the Translunar Injection, or TLI. The TLI maneuver breaks the bonds of Earth's gravity and sets the spacecraft on a course for the Moon. The interim cryogenic propulsion stage fires the RL-10 engine to complete the TLI burn that lasts about 20 minutes and increases the spacecraft's speed to more than 9,000 feet per second. Following TLI, Orion is committed to a lunar trajectory just 90 minutes after launch. The Orion stage adapter that connected Orion to the upper stage of the rocket will remain with the interim cryogenic propulsion stage as Orion separates from the stage about 2 hours after launch. Then 10 small satellites known as CubeSats will leave the Orion stage adapter and use their own propulsion systems to go to destinations, including the Moon, to perform experiments and technology demonstrations.
And now we want to put up our countdown clock for you. This is the T clock that you see in the upper left-hand corner of your screen. This reflects the time that the launch team is counting down, but does not include a half-hour hold that we have coming up. So the actual time until launch is 7 hours and 8 minutes, but we are 6 hours and 38 minutes away from going into a half-hour hold. And then once that half-hour hold is finished, they'll go into terminal count and the final T minus 10 minutes. To learn more about Artemis I and our mission around the moon, go to our website at nasa.gov/Artemis-1. nasa.gov/Artemis-1. It's nighttime here on the east coast of Florida, and we continue counting down to liftoff. Currently in fast fill for both the core stage liquid oxygen and liquid hydrogen tank. We've got another couple hours of that for the core stage. So far, the launch team not working any major issues. The range is go. Our weather is good, 80% go. Liquid hydrogen will finish in about an hour, and we'll be able to get started working the upper stage tanking. For now, this is Artemis Launch Control. And we are now half full of liquid oxygen. You're looking there at a shot of the liquid oxygen tank venting. That's super cold oxygen gas meeting the humid Florida air and turning into vapor. And there's a look at the numbers. On your left, you can see the core stage liquid oxygen is more than 50% full. Got about another hour and 20 minutes to go in fast fill. And then over on the hydrogen side, moving quick. More than 3/4 full. On a tank that is the largest liquid hydrogen tank ever made into a rocket booster. We also got an update from Johnson Space Center and the flight dynamics officer there, passed to us through PAO. There are 40 cutouts in our 2-hour window tonight. These are times in which we cannot launch the Artemis rocket. This is down from the 56 cutouts that were reported just a couple of days ago, but these numbers are regularly crunched and examined, looked at. The cutouts range from anywhere from a second or two to about a minute. So they're not a big impact today on the 2-hour launch window that we have that runs from 1:04 a.m. Eastern Time to 3:04 a.m. Eastern Time tomorrow. You're looking at the bottom of the Space Launch System rocket, the core stage with the 4 engines, RS-25s, built by Aerojet Rocketdyne. Those are heritage engines that came from the Space Shuttle program. And you can see the liquid oxygen vent at the bottom of the rocket as well, wafting up. A water vapor that's chilled from the liquid oxygen meeting the air. The team is also configuring the upper stage of the rocket, the interim cryogenic propulsion stage. Configuring its guidance and navigation. And at the very top, you can see the launch escape system, which covers up the Orion spacecraft, which is the spacecraft we're going to send around the moon with a launch tonight. And one of the major objectives is to bring that Orion back from lunar orbit faster and hotter than any human-rated spacecraft has ever returned back to Earth. And we now also understand that on this particular flight, it's been calculated that Orion's maximum distance from the Earth, once it gets into lunar orbit, is 268,553 statute miles. From launch to splashdown, the total number of miles is estimated to be 1,228,000, roughly. And Orion's going to get about 80 miles away from the moon. And we have cameras on Orion, in which we hope to bring you that imagery should we have a launch this evening, or should I say early tomorrow morning. We're moving along well. Currently, we are 6 hours and 15 minutes on the T clock, 6 hours and 45 minutes on the L clock. This is Artemis Launch Control. And we have an update now. The tanking fast fill for liquid hydrogen has completed. The fast fill has completed. And now we are in topping. Again, core stage liquid hydrogen fast fill is complete, and now we are at topping. And you can see the graphic there. We've still got about an hour left on the core stage liquid oxygen side to the left. Now currently 64% full. Currently had no issues. We went through the test on the liquid hydrogen side. Did get a leak rate at just over 4%, 4.3%, I believe. And but then it went back down, which is tracking exactly as the launch team expected it to, with the kinder and gentler, as they call it, loading procedure for liquid hydrogen. All great news there. And so as liquid hydrogen goes into topping, we continue to have the liquid oxygen in fast fill. And you can see the venting of liquid oxygen coming up from the bottom of the rocket. We've got an update on a mission that launched not too long ago called Capstone. This is a mission to test out the lunar orbit that one day Artemis will use to put our gateway station around in lunar orbit called the Near Rectilinear Halo Orbit. It's a special orbit. The Capstone mission operations team confirmed that NASA's Capstone spacecraft arrived at its orbit at the moon Sunday evening. The CubeSat completed an initial orbit insertion maneuver, firing its thrusters to put the spacecraft into orbit at 7:39 p.m. Eastern Time. Capstone is now in a near rectilinear halo orbit, or NRHO. And this orbit, of course, is the same one that will be used by Gateway, as I mentioned, the moon orbiting space station that will support NASA's Artemis missions. Capstone is the first spacecraft to fly NRHO. Getting an update now on the rocket. After 2 cleanup maneuvers, the Advanced Space and Terran Orbital team will review data to confirm that Capstone remains on track in the NRHO. Orion will be going to a distant retrograde orbit around the moon, but as I mentioned, follow-up missions will seek to go into the NRHO orbit. Just got an update from the launch team. Core stage is now in replenish, now having moved from topping into replenish, so it's at 100%, and the propellant that is boiling inside, being that liquid hydrogen is minus 423 degrees Fahrenheit, it is boiling the entire time inside that rocket, just as the liquid oxygen is, and you can see it venting out the side of the rocket. But again, liquid hydrogen now in replenish, which is a great milestone for the launch team. And now they're beginning to configure ICPS. We've had some RL-10 engine purges. They're purging the liquid hydrogen engine system. The core stage tanking must be complete before And you're looking at an engineer who is currently scanning the core stage thermal protection system. It's the butterscotch colored thermal protection system. It's spray on foam, which helps keep these super chilled propellants cold. They still boil and they still vent off, but an additional insulation helps slow the rate of that boil. And so if you were following our program, you know that we had some thermal protection system. Some of that thermal protection system has what's called cryo pumping. Small cracks in the TPS. It's not a problem for the rocket, but it can sometimes give off some vapor, as you see to the left side, lower left side of the screen. So the engineers will scan the TPS for any cracks, any frost balls, just making sure that they are keeping a constant eye on anything that happens in that TPS that might signal something more severe. But so far, to this point, all is well with the rocket. Coming up at 10:30 p.m. Eastern Time, we will have a special launch broadcast that will begin on NASA TV. Tell you all about the Artemis program. We have interviews with astronauts and some special features for you. We will continue the commentary that you're watching right now on the NASA Media Channel. This is Artemis Launch Control. As you can see on the screen, you can see the liquid hydrogen tank is 100% filled, all 538,000 gallons. Currently, it's boiling off, and that is being replenished. That's why they call it replenish mode. On the core stage, we're 3/4 filled. Core stage liquid oxygen currently flowing into the rocket. That's the long pole in the tent. Configurations are being made to prepare the upper stage for liquid hydrogen tanking. Everything's moving smoothly so far. It's been a relatively quiet countdown, which is great. I mentioned a little earlier the calculations on Orion's maximum distance from the Earth. We just learned it'll be 268,553 statute miles. And it'll come as close as right around 80 statute miles to the moon. Once in space, the Orion spacecraft will begin a 26-day mission. So let's learn more about that right now.
Orion will travel through the Van Allen radiation belts into the deep space radiation environment. The spacecraft's outbound trip to the moon will take several days, during which time engineers will evaluate the spacecraft systems and correct its trajectory if needed. As Orion approaches the moon, the engines of the European service module will fire to perform a powered flyby, which allows the spacecraft to target a distant retrograde orbit about the moon. At its closest approach, Orion will be about 60 miles from the surface of the moon. As the spacecraft flies around the far side of the moon, all communication with Earth is lost. Orion will be on its own. Mission Control will wait to acquire a communication signal from the spacecraft. Through cameras positioned inside and outside of the capsule, will capture a view of Earthrise for a new generation. The spacecraft will drift past the far side of the moon over the next several days. A second service module main engine burn will place Orion in a distant retrograde orbit. It will travel in the opposite direction from the path the moon flies about the Earth. The spacecraft will stay in that orbit for approximately 1 to 3 weeks to collect data and allow mission controllers to assess its performance. The spacecraft will use another precisely timed engine firing of the service module along with the moon's gravity for its return trip to Earth. After exiting the distant retrograde orbit, the engines of the European service module will fire to do another close flyby of the moon and aim towards Earth.
To learn more about the Artemis I mission, just go to our website, nasa.gov/Artemis-1. nasa.gov/Artemis-1. T-minus 5 hours and 37 minutes and counting until liftoff. That does not include a half-hour hold. Together, it will be 6 hours and 6 minutes away. This is Artemis Launch Control. configuration of the upper stage continues. The RL-10 purge for the liquid hydrogen on the RL-10 is complete. The liquid oxygen upper stage RL-10 engine system purge is now beginning. Again, liquid hydrogen upper stage RL-10 purge complete. Liquid oxygen upper stage RL-10 engine purge is now in work. These steps are done ahead of cryogenic tanking of the upper stage. That should happen in just a few minutes. We should start get moving with the hydrogen side on the upper stage. Currently still in fast fill for the core stage liquid oxygen. It's currently at 80% filled. We are currently L minus 5 hours and 43 minutes, T minus 5 hours and 13 minutes until liftoff of the Space Launch System from the Kennedy Space Center here in Florida. You're looking at the rocket on the pad, NASA's 32-story tall moon rocket, scheduled for liftoff at 1:04 a.m. Eastern Time, with a 2-hour window running to 3:04 a.m. Eastern Time. We have had a very clean count so far. We're running ahead of schedule as well, about an hour and 20 minutes ahead of schedule. The net's fairly quiet at this part of the countdown. Currently, we are tanking the liquid oxygen core stage, sitting at 90%, and we are fully tanked on the liquid hydrogen side. Looking at the engines and the core stage right there in the center of your screen, quite a bit of history there with those RS-25s. They were built by Aerojet Rocketdyne, and they are heritage hardware that's been upgraded and its performance increased, all 4 of them, substantially. But about that history, if you look to the left, engine number 3, that's engine 2058. And engine 2058, which flew on the space shuttle, flew 6 flights to the space station. Behind 2058 is engine number 4, identified with a 2060. And quick update, the LO2 engine system purge is complete on the ICPS. Again, LO2, liquid oxygen engine system purge, complete on the ICPS. Getting a couple updates on the nets at this moment. Listening to the launch team just there for a couple of moments. No major issue being reported. But as you're looking now, again, back to the engines, liquid oxygen venting up from the bottom. The engine in the back, 2060, engine number 4. That one flew on the space shuttle, including Hubble telescope servicing mission. And then to the front right, that's engine 2056, engine number 2 on the rocket. 2056 . 2056, actually. That was the one that did the Hubble telescope servicing mission. My apologies. Engine number 2 on the right, and then engine number 3 on the left. Engine number 4 is back left. That's 2060, and that one did the 3 space shuttle flights, including the space shuttle's final mission. But the one with all the star power is engine number 1, and it is on the back right in terms of the setup of these engines. Engine number 1 is 2045. That had 12 space shuttle flights on it, including John Glenn's flight. Astronaut John Glenn, as well as a senator, flew with that engine. And it also included this final space shuttle mission, the final flight, STS-135, the last space shuttle Atlantis, which is currently here at the Kennedy Space Center Visitor Center. The core stage in the middle, of course, that holds the RS-25s, that's built by Boeing Aerospace. The 2 side boosters there, built by Northrop Grumman. And to the top of the rocket, the Orion spacecraft is built by Lockheed Martin. And speaking of the Orion spacecraft, when it heads to the moon, that will be about 1,000 times farther from Earth than the International Space Station is from the Earth. Of course, the International Space Station orbits the Earth at approximately 250 statute miles above the surface of the Earth, and the moon is beyond 250,000 miles. The mission will be a 26-day mission if we lift off tonight. To learn more about the Artemis program, go to our website at nasa.gov/Artemis-1. Again, nasa.gov/Artemis-1. This is Artemis Launch Control. coming on console at the Johnson Space Center Mission Control is Judd Freeling and his team. Judd Freeling is the flight director that will lead his team tracking Orion from ascent through translunar injection. This is the third shift for the team at Mission Control Houston. And you're looking live at launch control here at the Kennedy Space Center in Florida. The top row is for the launch directors. And that row below is our NASA test directors, currently flying the ship, so to speak, overlooking the countdown and making sure that everything goes smoothly. And so far, everything has gone smoothly. Got a thumbs up just a couple minutes ago from one of the NASA test directors. Currently, they're working to configure the upper stage of the rocket, the ICPS, the Interim Cryogenic Propulsion Stage, that's built by United Launch Alliance. It's a modified upper stage from the Delta IV. Tanking-wise, we are currently sitting at 100% full for the core stage liquid oxygen and 99% filled on the liquid oxygen side. T-minus 4 hours, 58 minutes until liftoff. L-minus 5 hours, 28 minutes until liftoff. This is Artemis Launch Control. And we just reached topping for the core stage. Liquid oxygen topping on the core stage tank. Just moments ago. Okay, we've just reached replenish for the core stage liquid oxygen tank. Again, replenish for the core stage liquid oxygen tank. A major milestone reached this evening, as now both tanks of the core stage have been filled. Both are in replenish. Both are boiling propellants and thus venting off the gas that results, as you can see there on the left side of your picture, as the liquid oxygen side vents off that super cold oxygen gas that then condenses the water in the atmosphere and creates that vapor plume. And now we have just started upper stage loading operations, shifting now to tanking the upper stage of the rocket, the interim cryogenic propulsion stage. It too has a liquid oxygen tank and a liquid hydrogen tank, much smaller though. LH2 chill down now in work for the upper stage of the rocket, which holds 10,000 pounds of liquid hydrogen. On the liquid oxygen side, there are 53,000 pounds of capacity. The RL-10 engine Okay, we are now loading LH2 in the upper stage. Again, LH2 loading in the upper stage, that's liquid hydrogen. Listening to the team on their communications channels. All right, very good. And so the propellant for the upper stage, as you're looking at that shot right there with the two spotlights illuminating the Space Launch System out at Launch Complex 39B here at the Kennedy Space Center in Florida. The propellant will flow through the umbilical at the 240-foot level, just below the one that you see to the left in the foreground. It's in the background there. And so now we are tanking the upper stage. SLS Chief Engineer John Blevins calling this a very clean count. So far. We're headed to a liftoff time of 1:04 a.m. Eastern Time on the 16th. We have a 2-hour window. Hopefully we won't need it. The liquid oxygen team reporting out that they are now ready for upper stage loading operations. Again, the liquid oxygen team ready for upper stage loading operations to the interim cryogenic propulsion stage. Core stage liquid oxygen tank is at 100% and is in stable replenish. It took roughly about 4 hours and 23 minutes to tank the core stage from the moment the go was given by the launch director at 3:22 p.m. Eastern Time. Charlie Blackwell Thompson, Artemis launch director, gave the go. And now loading of the upper stage is underway. And so they're giving the call right now for the LOX team, liquid oxygen, to start their loading operations. T-minus 4 hours and 12 minutes and counting here at the Kennedy Space Center in Florida. You're looking live at the Space Launch System rocket with Orion at the top, getting ready for a launch to the moon. We are currently in the midst of cryogenic tanking the upper stage of the rocket after a 4-hour and 23-minute successful tanking of the lower core stage. Currently, both liquid oxygen and liquid hydrogen on the upper stage are in fast fill, which is a great milestone. The ICPS, the upper stage of the rocket, that's the interim cryogenic propulsion stage made by ULA. It's a modified Delta upper stage. Has 10,000 pounds of liquid hydrogen and 53,000 pounds of liquid oxygen. The liquid oxygen team reporting out that they'd like to pick up the pace a little bit on their side of the upper stage. So far, we've had a pretty clean count. It all started at 3:22 p.m. Eastern Time when the launch director, Charlie Blackwell Thompson, gave the go for cryogenic. Finished that tanking at 7:45 p.m. Eastern Time. We are tracking towards a 1:04 a.m. Eastern Time launch on November 16th. You'll look at the clock at the upper left-hand corner of your screen. That is a time. So you have to add a half hour to that to get the true time to launch, which we call the L clock. That half hour is used by the launch team to do any catch-up work and prepare for the final 10 minutes of the count, which is called terminal count. The launch team configures the rocket up until point, and at T-minus 10 minutes, it is then given over to the ground launch sequencer, which is software and a computer that then configures the rocket, bringing on all of the high energy systems in the last few minutes as they count down to liftoff. You're looking at the lower portion of the rocket and the midsection of the rocket. You can see the venting happening as the liquid oxygen is now venting from the ICPS. The ICPS has multiple liquid oxygen vents, so you can see them in 2 locations. And then the full shot of the rocket there, you can see the liquid oxygen tank in the core stage currently venting out from the upper portion of the rocket. That liquid oxygen tank sits in the upper third of the core stage. Throughout the evening, we've been telling you a little bit more about the Artemis mission. The primary objective of the Artemis I mission and this launch tonight is to send the Orion spacecraft around the moon and then test its ability to return from lunar orbit and endure the extreme heat of re-entry.
Interagency team, including the United States Navy and Air Force, along with NASA engineers and technicians, will begin preparations for Orion's return home. During the journey home, Orion will maintain the desired tail-to-sun attitude to optimize spacecraft cooling and maximize power production in the deep space environment. Another week passes as Orion coasts towards Earth. The European service module separates behind Orion and is jettisoned. Following separation, engines on the back shell of Orion will ensure the spacecraft is properly oriented as it travels in the direction of entry interface at an altitude of 400,000 feet. At entry interface, Orion will enter the Earth's atmosphere, traveling at a speed of 25,000 miles per hour, decelerating at a rate up to 4 times the force of gravity. The heat shield will protect the spacecraft from temperatures half as hot as the surface of the sun, approaching 5,000 degrees Fahrenheit. Orion's precise deployment sequence of 11 parachutes assembled in mid-air will begin. As Orion slows, the 3 forward bay cover parachutes separate the protective thermal cover that sits over the parachutes. Drogues used to slow and stabilize the crew module during descent cut free, and 3 pilot chutes are deployed, used to lift and deploy the 3 main parachutes. At 9,000 feet in altitude and a speed of 130 miles per hour, the 3 main parachutes, 116 feet in diameter, will slow the crew module to a safe landing speed of less than 20 miles per hour. After a 4 to 6 week long mission, and after traveling more than 1.3 million miles, Orion will target a landing 16 minutes after entering Earth's atmosphere. Following splashdown, Orion will remain powered for operations and recovery teams to conduct inspections. Orion will then be pulled into the ship and secured for its return to Kennedy Space Center. We are going together and invite you to follow along at www.nasa.gov/Artemis-1.
To learn more about Artemis I, get to our website, nasa.gov/Artemis-1. Again, nasa.gov/Artemis-1. This is Artemis Launch Control. quick update on the tanking of the upper stage of the Space Launch System. We are in fast fill for both liquid hydrogen and liquid oxygen. Liquid hydrogen stands at 18% filled. Again, 18% filled on the liquid hydrogen side, and we are 44% filled on the liquid oxygen side. Both of these are the tanks on the upper stage of the rocket, the ICPS. Again, 18% filled for LH2, 44% filled for liquid oxygen. T-minus 3 hours, 38 minutes and counting here at the Kennedy Space Center in Florida, where we are waiting the launch of the Space Launch System rocket. Currently on the pad, you're looking at venting from the upper stage of the SLS as we are in fast fill for both the liquid oxygen and liquid hydrogen. Just got a weather update to the launch director, Charlie Blackwell Thompson. 45th Weather Officer, Launch Weather Officer Melody Lovin, giving some good news, saying that the trend of the weather is our friend. Some thicker clouds are moving into the area over the launch pad, but it was only just one thick cloud in the area, would have violated flight through precipitation rule, but it is now thinning out, and that was the only one they're tracking, not within the launch area. And so because the clouds are starting to thin over the launch complex, we are back to 90% go for launch. Again, we are back to 90% go for launch weather. Only concerns that the LWO is tracking at this moment is the thick cloud rule and the cumulus cloud rule. You don't see it in the shot. It is nighttime, but early in the evening, we did have some cloud cover over the area. But conditions are calm enough for the LWO to bump up the go for weather to 90%. Great news there. Launch director has asked for another update in just about an hour on the weather. And I just heard a completion of LOX fast fill complete for the upper stage liquid oxygen tank. And now they are proceeding with an LO2 tank valve test. Great news there. We're still tanking the liquid hydrogen in the upper stage. Again, another milestone reached. Fast fill is complete on the upper stage liquid oxygen tank. This is Artemis Launch Control. T-minus 3 hours and 17 minutes until liftoff of the Space Launch System. That's L minus 3 hours and 47 minutes. We have a half-hour hold that we're going to be going into at the end of, towards the end of the countdown. I want to give you an update now. The launch team is tracking an intermittent leak on the cord stage replenish valve. This is on the hydrogen side. The location is at the base of the mobile launcher. The team reporting to the NASA test director, it's going in and out of leak measurement. Momentarily, it spiked to 1.5%, but then came back down, and they continued to monitor it. Going over 1% is the violation. It was only there for a short period of time, came back down. It's 1% is the violation, Mark, as I understand from the engineers, because this is an open air sensor, different from the closed volume sensors on the previous leaks, if you may recall from the previous launch attempts. So the team is monitoring it. If it were to continue to degrade, it would put the upper stage LH2 into stop flow. It's back down at the moment into the 0.2 range. And so, again, the team just continues to monitor, but they have advised launch director. Again, the team just continues to monitor, but they have advised launch director Charlie Blackwell Thompson that there's not a lot they can do from here. If it were to go back up above 1%, they would have to send the red crew into the pad. Now, that's the team that is specifically trained to go into the launch pad with a tanked rocket and do work. But we're not there yet. I want to emphasize, not there yet. Again, the team's monitoring this. Of course, we'll keep you updated. Percentage-wise, let's talk about the upper stage. We are at 60% filled for the liquid hydrogen upper stage. For liquid oxygen, we're almost filled, currently at 92%. Again, upper stage, 60% for liquid hydrogen and 92% liquid oxygen. We're in fast fill for liquid hydrogen and topping for LO2. Quick look at the core stage, just to review. We can put up a graphic that'll give you a check on that. Core stage reached its replenish mark, which means fully tanked and filled at 7:45 p.m. Eastern Time. And there you see the graphic. 100% on both tanks. The core stage, of course, 750,000 gallons of super chilled propellants. And of course, we'll continue to track the countdown. This is Artemis Launch Control. Quick update, we are now in stop flow for the liquid hydrogen core stage. Again, we are in stop flow for liquid hydrogen core stage due to an intermittent leak on the replenish valve. Okay, the NASA test director has advised that they are now putting a plan into work to send the red crew into the pad. Again, the NASA test director putting together a plan to send the red crew into Launch Complex 39B and the mobile launcher area. Discussion is about an intermittent leak on the upper stage. I'm sorry, intermittent leak for the core stage replenish valve, which is inside the mobile launcher. Now it's in the planning stages, so they are not going out there yet. But again, the team being mobilized. The red crew operates out of a building about 4 miles away from the launch pad. Discussion is around torquing down the packing nuts at the base of the ML. The leak has increased. And so the team currently taking planning action to send that red crew team in. Of course, we'll keep you updated on the latest. This is Artemis Launch Control. Upper stage LOX is in replenish. Upper stage liquid oxygen is in replenish. Meanwhile, the launch team continuing to work a solution to an intermittent leak at the core stage replenish valve. It is on the side of the mobile launcher, and the discussion is around sending a red crew into the launch area, up to the pad, and having them go up and torque bolts connected to a valve that has shown some intermittent leaking. They're currently discussing it now. Stand by for more information. This is Artemis Launch Control. Okay, T-minus 2 hours, 44 minutes and counting. Have an update on the situation with the intermittent leaky valve for the core stage liquid hydrogen. The NASA test director just briefed about getting ready to send the red crew onto the launch pad. The cause is an intermittent leak on the core stage liquid hydrogen replenish valve. Its location is on a skid on the side of the mobile launcher. As a result, the liquid hydrogen for the core stage is in stop flow, coming out of replenish, which replaces the liquid hydrogen that is boiled off. And so the only way to fix it at this moment is to send a red crew out to the pad. This is inside the blast danger area and it is considered a hazardous operation. Here's the plan. The launch team is going to send 2 technicians with a safety lead to compartment AB-12. That's on the side of the mobile launcher to torque packing nuts to resolve the intermittent leak. The techs will take 2 vehicles, drive up the pad surface. They'll exit their vehicles, go up the stairs to the 0 deck, then downstairs to the location where the valve is, and then torque the packing nuts. The red crew says it should take them about 15 minutes to do. Then they would return to their vehicles from the route that they came in on. Now, emergency services, EMS, have been notified along with pad rescue, and they are standing by for the start of this operation. And right now, the NASA test director is briefing the launch team on the procedures. HazGas will be closely monitoring sensors that are with the technicians for high concentrations of oxygen, hydrogen. And so there is a high degree of focus by the teams, especially the safety team, hazardous operations, currently getting ready to be underway in just a few minutes. Again, intermittent leak on the core stage liquid hydrogen replenish valve. It's on a skid on the side of the mobile launcher. The red crew team has been mobilized. The plan to torque down bolts inside the ML where the valve is has been briefed to the launch director. It's been signed off on, and we're awaiting the departure of the red crew team out to the launch pad. Stand by for more updates. This is Artemis Launch Control. All right, Launch Director Charlie Blackwell Thompson just gave the go for the Red Crew team to enter Launch Complex 39B that you see there on your screen to work a issue with a leaky replenish valve on the side of the mobile launcher. The mobile launcher is the gray structure that you see there. The Red Crew team is a highly trained group of individuals, 2 technicians and 1 safety lead that will be making entry into the pad to tighten down bolts, the packing bolts on the valve. It is a straightforward job as described to me by the launch team. Once they're at the valve location, the Red Crew has advised it should take about 15 minutes to do the work. So they should be in and out of there relatively quickly. There's no troubleshooting to be done. They have a specific task that they're going to go in there and perform. And then they'll depart the pad. It is a hazardous operation inside the blast danger area. And the launch team will be tracking their every movement. EMS is standing by, along with pad rescue. We'll keep you updated. This is Artemis Launch Control. Okay, you're looking at a live shot of the launch pad and the two vehicles at the bottom that just arrived, the two technicians, and the safety representative. This is the red crew that is specifically tasked to go out and tighten some bolts on the core stage hydrogen replenish valve on the side of the mobile launcher. It is a hazardous operation. But as you can see from this camera view, and I have view of the safety team here, they're monitoring multiple camera views and watching the red crew as they do their work, looking to fix an intermittent leak that popped up about an hour ago. T-minus 2 hours and 13 minutes. We are tracking the red crew, 2 technicians and a safety representative that have made entry to the launch pad and are currently inside the compartment where the leaky replenish valve is. Again, the red crew, which is a specially trained crew to work in and around a fully tanked rocket, is inside the compartment area where the leaky replenish valve is. It's on the liquid hydrogen side. Their job is to torque down the bolts, the packing nuts on this particular valve, and that is, as I understand it from the launch team, currently in work. Safety team is watching on cameras that are in and around the launch pad. This is not a totally uncommon operation. The red crew, there's a number of individuals who stand by ready to do work on the red crew, who are specifically trained in their areas of expertise when they have to put hands on at the launch pad after or during tanking. So this is likely to eat into the launch window. An update on the tanks. We are in replenish on both the liquid oxygen core stage and upper stage. We are in stop flow for liquid hydrogen on the upper stage and the core stage. And that stop flow, of course, is related to the intermittent leak on the replenish valve that's on the side of the mobile launcher. We saw the red crew go in. The red crew estimates it'll take about 15 minutes to complete the job. And then they're coming right back out. This is Artemis Launch Control. T-minus 2 hours and 7 minutes and counting. We are currently tracking work done by the red crew, currently out at the launch pad, a specially trained crew, torquing down some bolts on a hydrogen replenish valve. The safety team has eyes on it. They're currently doing that work. I want to make a programming note for you. Currently, if you're watching NASA TV's main channel, we are now going to begin the special launch broadcast that we have planned. Meanwhile, over on the NASA television media channel, we will continue with operational commentary. Again, we're getting ready to start a launch broadcast, a special launch broadcast on the NASA TV main channel, but we will maintain operational commentary on NASA TV's media channel. Please stand by for that. This is Artemis Launch Control.
"50 years after we last left footprints on the moon, NASA's Artemis I is our first bold step towards getting us back there and pushing us farther than we've ever been before."
Landing a man on the moon and returning him to safety to the Earth.
Tranquility Base here. The Eagle has landed.
You are looking at the world's most powerful rocket and Orion spacecraft live on Launch Pad 39B. Artemis I embodies the hard work of thousands across the world, determined to explore for the benefit of all. Welcome, and thank you for joining us live at Kennedy Space Center, where the energy here is palpable as we attempt to make history today. I'm Megan Cruz, and this is NASA astronaut Kayla Barron. Kayla, great to have you here again.
So awesome to be here tonight.
Well, some of you may know this, but Kayla served as a mission specialist for NASA's SpaceX Crew 3 mission. It launched to the International Space Station in November of last year, and she lived and worked there for about 6 months. Today, I am thrilled to have her here with me to talk about this rocket behind us illuminating beautifully the night sky here in Florida.
Yeah, it's so awesome to be here tonight. When I first walked up and saw the view from the desk here, I was just blown away by how close it is and what an awesome view it's going to be when we get to launch time.
Yeah, it's a magnificent view, and I know you're especially excited about this because if we launch today, this will be the first launch that you actually see from the ground.
Exactly. I've never been able to come see a launch in person, except for my own, of course, but that's a little bit different perspective.
Very different, yeah.
But to be here for the world's most powerful rocket and the first test flight of Orion and SLS is just amazing.
Yeah. So our 2-hour launch window opens at 1:04 a.m. Eastern Time. So Kayla, tell everyone, why are we returning to the moon?
We are returning to the moon to learn more about it. The moon is a perfect place to learn more about our solar system, how the moon formed, but also how the Earth and the rest of our solar system formed. And we know so little about it. There's a lot to learn by returning there and doing some awesome geology work, but it's also the perfect proving ground for our continuation, exploring further into our solar system and eventually going to Mars.
Right.
We need to test all the operations concepts, all the equipment, habitats, rovers, suits, all of these things. And so it's the perfect place to test all of those things out and learn the things we need to do something that's almost hard to wrap your head around, going all the way to another planet.
Absolutely. Really ambitious goals, and it all starts here with Artemis I. So Artemis I is the first flight test of NASA's brand new Space Launch System, or SLS rocket. It's the world's most powerful rocket and will send an uncrewed Orion spacecraft farther around the moon than any of the Apollo missions before it. Artemis II will be the first crewed mission around the moon, and then Artemis III will use a brand new human landing system to bring astronauts to the surface of the moon. Future Artemis missions will dock to Gateway, NASA's lunar orbiting space station, before descending to the moon. So Kayla, what must we demonstrate with Artemis I before we put astronauts on board for those future crewed missions?
This is our first integrated test flight of the rocket, the Space Launch System rocket, and Orion, the capsule that crew will fly in on Artemis II. And so it's really important for us to put all of those systems together and actually send them to do a mission, test all those systems in real time in concert together. We do a lot of testing before we get to this moment, before we get to launch day, but it's not integrated, and we're not actually putting the systems under all of the real world stresses they're gonna see.
Right.
So we wanna see the rocket perform, we wanna see Orion make it around the moon, go super deep into space, and then come home and successfully re-enter. So the heat shield actually has to withstand the fastest and hottest re-entry we've ever seen in human spaceflight. So that's a big thing we want to see. The heat shield perform successfully, and then of course recover the vehicle, test all of that. So it's a lot, but it's the important first step before we put crew on the vehicle.
Yeah, lots of eyes on this one for sure. So tanking of the rocket began at 4:30 this afternoon. NASA's Daryl Nail is inside with the launch team and has some information about an issue they're currently working.
Right, Megan, the launch director gave the go for tanking shortly after 3 p.m. this afternoon, but as of right now, there is a red crew, as they are named, a specially trained team of individuals out at the pad making an unplanned change to a replenish valve on the liquid hydrogen side. There are 2 technicians and a safety representative that are right now working inside the mobile launcher. It's in an open air area that has a replenish valve that goes to the liquid hydrogen side of the core stage. Now this happened roughly earlier this evening, probably about an hour ago, when a leak was detected at the core stage liquid hydrogen valve by the launch team here inside firing room 1 at the Launch Control Center. Unfortunately, the team here was unable to remedy the leak remotely, and so it became necessary to send a crew of individuals, called the Red Crew, out to the launch pad to make a hands-on fix, so to speak, to that valve. What they're doing is they're torquing down bolts that are on the valve. They believe that by torquing these bolts down, they'll get a better seal on that replenish valve, and that should remedy the leak. The leak was detected by the hazardous operations team here inside the launch control when the percentage of hydrogen went above 1%. Now that's significant for this particular area because it is an open air location, the skid valve that runs the liquid hydrogen into the core stage. And we had reached replenish when this leak was detected. Over on the liquid hydrogen side, of course, there's two tanks on the core stage, liquid oxygen and liquid hydrogen. Both had been topped and gotten into replenish when this leak was detected. Currently, liquid oxygen is topped off and stable in replenish, but the liquid hydrogen is in stop flow at the moment, which will prevent them from proceeding forward with a launch until that leak is remedied. Again, this red crew is inside the area, inside the blast danger area, working inside the mobile launcher, torquing down those nuts that are associated with the replenish valve for the liquid hydrogen side of the core stage. Of course, we'll keep you updated on the operation. In the meantime, I'll send it back to Megan.
Thank you for that update, Daryl. And yes, we are looking forward to your next update as to what happened with the red team out there on the pad. Now, today will be our third opportunity to launch Artemis I. The launch team called off the first two attempts due to issues while loading propellant into the rocket. The team addressed those issues and planned to try again in September, but then Hurricane Ian made landfall here in Florida as a strong Category 4 storm. Satellite imagery there shows us the storm went right by launch pad 39B. Thankfully, the rocket was safe inside the vehicle assembly building at the time. The team rolled the rocket back to the pad 2 weeks ago, and it stayed there through Hurricane Nicole, which made landfall last week as a Category 1 just south of Kennedy Space Center. Teams inspected everything after the storm and confirmed they were ready to try and launch today. Now, Daryl is one of a team of people helping to bring you today's uncrewed flight test. We have Jasmine Hopkins nearby, also inside with the launch team, who will interview some key players in our return to the moon. We also have Leah Cheshire inside Mission Control at Johnson Space Center. Dan Hewitt with a new tool we're excited to show you. Leo Martin at the Kennedy Space Center Visitor Complex. And finally, Brian Sizik with the U.S. Space Force monitoring weather. With 1 hour, 54 minutes until liftoff. How are we looking, Brian?
And you showed we certainly had some interesting weather here in East Central Florida over the last several months, but I'm happy to report we're not looking at any type of satellite imagery like the ones you just showed. Overall, weather is looking quite favorable as we head throughout the countdown and into the launch window. So here's what we're looking at right now, really just one area of concern. That's these upper level clouds that are moving in. So there's a cold front in the Gulf of Mexico right now. That's producing some showers in the Gulf, but those are not expected to get to us by the launch window. But the upper level winds are bringing in some cirrus clouds that are moving in. Now they're high enough and thin enough where they're really not going to be a concern. For it to be a thick cloud layers rule violation, they'd have to be a lot thicker and a little bit lower in the atmosphere in order to hold a charge. So that's what we're looking for in these lightning launch commit criteria, not just natural lightning, but rocket triggered lightning potential, as some of these clouds can hold a charge. A rocket can actually induce a lightning strike in an atmosphere that's not strong enough to produce a natural lightning strike. So that's really what we're watching. But right now, weather is go. These clouds, as I said, are high enough and thin enough where they're really not going to be much of a concern. But we are going to be watching it. My colleagues Melody Lovin, Mark Berger, and the rest of the launch weather team will be watching this very closely as we head closer to T0. So let's take a look at the graphic. The latest briefing, 90% go. Really the only concern being the thick cloud layers rule and a very small concern for the cumulus cloud rule. But overall, the weather is looking favorable. As I said, right now, weather is go. Those clouds are high enough and thin enough where we do not expect them to be a concern. So I'm happy to report a very favorable launch forecast as we head closer to T0. Megan, back to you.
Don't you just love hearing 90%? You know, that's wonderful, especially here in Florida. You know what I mean? Weather can really be kind tricky here in Florida. So 90% is perfect. Now, Florida's Space Coast has been the primary launch site for NASA's crewed missions for the last 6 decades. First Apollo, then Shuttle, the Commercial Crew Program, which Kayla flew up as a part of, and soon Artemis. Let's go now to NASA's Jasmine Hopkins.
Thank you so much, Megan. We're here in the Launch Control Center amid all the excitement in Firing Room 2, and I'm so glad right now to be joined by our Kennedy Space Center Director, Janet Petro, and our Deputy Director as well, Kelvin Manning. Thank you both for being here.
Thank you, Jasmine.
Hi, Jasmine.
We are so glad to have you. This team has overcome a lot to get to today. We are no stranger to storms on the Space Coast. We overcame Ian, and then Nicole. Janet, how did we embrace the challenge?
That's my line, Jasmine.
Yeah.
I gotta say, I couldn't be more proud of the team out here. Everything we did to get to this point, and then to have those 2 storms thrown at us at the last minute. Nicole, all the evacuations. As you know, one time we remained at the pad, and the other time we had to roll back to the VAB. But I got to tell you, across the workforce, whether it was our program people, across the agency, our institutional support organizations, they all came together and worked as a team. And so here we are tonight, looking forward to a great launch.
Right, we're a very strong team, and we have been at this for years, for decades. We started off during the Apollo program, but now we've evolved into what we're calling a multi-user spaceport. Kelvin, what does that mean?
So when we were getting ready to retire the space shuttle, a lot of people thought we were going out of business, literally shutting down. But our leadership team, we had a vision to create what we called a multi-user spaceport to become the world's premier government and commercial spaceport. And so that's happened over the last 10 or so years, probably a lot faster than we thought it would. But right, if you would say, you ask us, well, what's the future look like? I'll tell you, we're just getting started.
Right, the future is very bright for us, and this is a really big day for NASA. I mean, Artemis launch, but an even bigger year for Kennedy Space Center, the Diamond Anniversary, our 60th anniversary. Janet, how have we commemorated that big milestone?
Oh, we've had a whole bunch of celebrations all along this year. As you know, Kennedy became a center back in 1962. As you said, we've been celebrating all year long, and I can't think of a better way of culminating our Diamond Anniversary with a launch of the Artemis for the Artemis generation later this evening.
Right, that is so exciting. And what does it mean for both of you to be leading the center at one of our busiest cadences we've ever seen? We've had over 40 launches this year alone. What has that been like?
We're gonna get past 50 tonight, I think. But for me, I'm incredibly honored to be leading this team. It really is all about the team and the workforce. We have such a highly skilled, a highly dedicated, a highly motivated workforce. We have an incredible mission, and we all come together and embrace the challenge and make things happen.
Right.
Yeah, it is a privilege to work here, and it's not about us. Like Janet said, it's about the people.
It really is. It's about this great team. Janet, Kelvin, thank you both so much for being here tonight. We really appreciate it.
Thank you, Jasmine. Go Artemis.
Yes, go Artemis.
Go Artemis.
Absolutely. Megan, back to you.
Great to hear from them. So 1 hour and 48 minutes and counting till our 2-hour launch window opens. We heard Dale report out that there is a team at the pad working an issue. So why don't we go back to him now to see if he has an update for us.
Yeah, Megan, now continuing to track the Red Crew's work at the launch pad. This is a specially trained team of 3 individuals, 2 technicians, 1 safety representative who are currently right now inside the mobile launcher at the base of the launch pad. They are doing work on a replenish valve, currently torquing down the bolts in order to remedy a leak in that replenish valve that was detected a little over an hour ago. Now, this is significant because currently with a leak, they have had to go into what's called stop flow on the liquid hydrogen tank of the core stage. Normally, under replenish, they continue to flow liquid hydrogen into the tank as it boils off in order to maintain a level of around 100%, but that has been in stop flow. And so at this moment, we are slowly losing liquid hydrogen in the core stage hydrogen tank. The Red Crew went in and is currently working a little longer than expected on the issue. It was estimated that it would take 15 minutes to do the work, but as we're now finding out, the Red Crew is torquing down the bolts and then backing out of the area and allowing the launch team to cycle the valves to test to see if they've got that leak fixed. So as they do this, we understand they will cycle this work, go in, cycle the valves, torque them down again if it continues to leak, and then back out and test the work. And this may continue until they have it fixed. The red crew going onto the launch pad isn't a totally uncommon occurrence, certainly new with the Artemis program, but work like this was done in previous space programs. The red crew is specially trained for this work. They are accustomed to working around in hazardous operation, especially a fully tanked rocket. Again, we are tracking Red Crew's operation out at the pad. It's expected that this will eat into the launch window, which currently we have liftoff at 1:04 a.m. Eastern Time, but the window runs 2 hours to 3:04 a.m. Eastern Time. Again, monitoring the Red Crew's work. We'll have more updates for you a little later on. For now, back to you, Megan.
Thank you, Daryl. Some quick programming notes. For the first time ever, we are broadcasting a launch in 4K. You can watch it on NASA's YouTube channel or check your local provider to see if you have NASA's UHD channel. The audio of our broadcast is also available on the local amateur VHF and UHF radio frequencies you see at the bottom of your screen. So if you're here along the Space Coast and interested in that, make note of those frequencies now. Or you can watch today's launch with live commentary in Spanish. That broadcast starts at midnight on NASA en Español's YouTube page, which we're showing you now at the bottom of your screen. Now, Kayla, why did NASA choose the name Artemis for our return to the moon?
Well, in Greek mythology, Artemis is the twin sister of Apollo. So it's really a connection back to the Apollo era, the amazing things we did as part of the Apollo program. But we wanted to give a nod to the future. You know, it's a new set of missions. We're with new objectives. So it's a connection to the past with an eye towards what we might do as part of the Artemis generation.
Yeah, let's talk about what those future ambitions might be. I mean, landing the first woman and first person of color on the lunar surface, that is a worthwhile ambition.
Oh yeah, absolutely. I think we've come a long way since Apollo in so many ways in the space program, but one of the ways we've evolved is our astronaut corps more closely reflects the nation it represents now. Sure. So those crews will be more diverse, and we think those diverse perspectives, not only in our astronaut corps, but our larger team, only make us a stronger one.
Yeah, all right. Well, coming up, we are going to hear from some of the Apollo astronauts and learn more about what we will accomplish for humanity by going back to the moon. We'll meet some of the women shattering glass ceilings to bring Artemis to life, including NASA's first female launch director. We'll also show you the Space Launch System up close and what happens when the cutest group of visitors gets the surprise of a lifetime. Plus, we'll take you around the world to show you how people are marking this historic mission. And Kayla and I will also take your questions live. You can send those our way by using the hashtag Artemis. We already have some questions from some celebrities. I know you're going to love these questions. So you're going to have to keep watching to find out who sent those in. And we also invite you to share your moon-inspired content using the hashtag NASA MoonSnap. Here's a sample of some that's already been sent in. This one's beautiful. The flower in the foreground there, the moon in the background illuminated so beautifully.
Here's an awesome one. It looks like we have an eagle here flying over the moon. Just beautiful. It's been really cool to see all these artistic submissions.
Oh yeah, really creative. And we're going to compile as many as we can and show them later in the broadcast. Now, let's check back in with Daryl. We do like to check in with him as much as possible to see if we can get any updates from the launch team. Go ahead, Daryl.
Yeah, Megan, we just saw the red team give a thumbs up to the camera as they are doing their work out at the launch pad. Currently, they're torquing down some bolts to the specification required in order to try and stop what has been described as an intermittent hydrogen leak in the area. It went above the 1% threshold, and so that is a violation of the HAZGAS limit in that area. The team continuing to work. As you look at the rocket on the pad, they were called out to the pad about a half hour ago, and they appeared to be making their way, at least have stepped back from the area of work. The way that the workflow has been going is they torque down the bolts, step back a little bit. The launch team then cycles the valves to check to see if the leak is still there, and then they come back in, and this has happened a couple of times, and start torquing the bolts again. The rocket was nearly fully tanked. The core stage was in replenish for both hydrogen and oxygen. The upper stage had nearly been finished when the leak was detected, and the countdown, though it is continuing, the rocket, the leak had to be addressed in order for the launch to proceed. The replenish puts the hydrogen back into the tank after it boils off, and so currently we're in a stop flow which no longer allows a replenishment of the hydrogen tank, and that would not allow us to have a launch without those tanks being in total replenish, and also in a vented configuration, which has also been put on hold. I'm sorry, not a vented configuration, but rather an engine bleed has been stopped. And so that would need to continue as well in order to get the engines conditioned for launch. That's the latest here from Firing Room 1 at the Launch Control Center. Megan, we'll send it back to you.
Thank you, Daryl. 1 hour, 41 minutes until, again, the planned start of the 2-hour launch window. Right now, let's head over to the Apollo Saturn V Center at Kennedy Space Center's Visitor Complex, where NASA's Dan Hewitt is just inside in front of a Saturn V rocket, which is the only vehicle to date to carry humans beyond low Earth orbit. He's going to show us what he has behind us there, the moon board. It's an interactive tool.
Yeah, thanks, Megan, and welcome, everybody. We're in the Saturn V Center, fitting that the rocket that carried astronauts to the moon of Apollo is just over our shoulder as we meet the rocket that's going to do it with the next generation under Artemis. So SLS, the Space Launch System, is out on the pad right now. It's on the mobile launcher. Before we jump into that, just to give you some perspective, so that valve that Daryl's been talking about is in the base section of this mobile launcher down here. That's different from the areas we were focused on in August and September in these 33-foot-tall tail service mast umbilicals that are delivering the hydrogen and oxygen to the core stage of SLS. But let's jump right in. A couple of key components to SLS. We're going to start here on the sides with the solid rocket boosters. If they look familiar, they're derived from those that flew the space shuttle. In fact, some of the segments of these boosters today were flown on previous space shuttle missions. We call them solids because of the type of propellant inside. If you were able to look in, you would see a mix of ammonium perchlorate, aluminum powder, and a binding agent called polybutadiene acrylonitrile. That's your expert vocabulary word for the day. Now, as these are firing, they're providing more than 90% of the steering and 75% of the thrust as SLS makes its way uphill. And those are attached to the core stage, 212 feet tall, 5 major sections. We're going to start at the fun part down here on the bottom. 4 RS-25 engines, again, derived from those that flew the space shuttle. In addition, we have this core engine section here where we have all of their necessary plumbing, also the connection points where we're feeding the propellants into the core stage itself. And as these are firing, each one providing up to 500,000 pounds of thrust during operation, consuming 1,500 gallons of propellant every second as they go uphill. Now, these are liquid rocket engines, which means you need a fuel, about 500,000 gallons of liquid hydrogen, and an oxidizer, about 200,000 of liquid oxygen up here. That hydrogen gets fed through feed lines down at the bottom of the tank here. The oxygen coming from these 2 feed lines you see running down out of this, the intertank section. The intertank also has the upper attachment points for the solid rocket boosters. The bottom attaches down here at the engine block. Now, all the way up top, we have the forward skirt. It's where you have your core avionics, your brains for flying SLS, as well as connections to the mobile launcher and some antennas. And if we zoom in, why does it look all bumpy? We have a spray-on insulation on the core stage. These propellants are stored at cryogenic temperatures, hundreds of degrees below 0 Fahrenheit. And so we have to try and keep them as cold as possible. Now, underneath this upper skirt, we have the second stage, the Interim Cryogenic Propulsion Stage, or ICPS. This is a modified upper stage from the Delta IV family of rockets from United Launch Alliance. Single RL-10B-2 engine, also propelled by liquid hydrogen, liquid oxygen. This is used for our in-space propulsion maneuvers, critically that translunar injection, which is going to give us the energy to go beyond low Earth orbit and head out to the moon. Altogether, that's the Space Launch System. It's going to be making its first flight, hopefully today. It's going to be a heck of a show. Let's get back to the countdown. I'll send it over to you, Megan.
Thanks, Dan. 1 hour, 37 minutes and counting until our 2-hour launch window opens tonight. The Space Launch System rocket and Orion spacecraft together, standing just taller than the Statue of Liberty at Launch Pad 39B. It's the culmination of years of development and thousands of tests. Here's a look at its path to the pad.
The Space Launch System is really the backbone of the Artemis missions. It's the truck. It's the big carry vehicle.
It allows us to carry both crew as well as the equipment that we need to live and work on the moon.
60 years ago, NASA was in a race to get to the moon. This time is more than just a race. It's about establishing a long-term presence.
Can you imagine rolling the Statue of Liberty out to put at the pad? That's what we're doing.
It will lift up from Earth with more power than the Saturn V, which was the first vehicle to take us to the moon.
Artemis is our next giant leap.
The difference between the Apollo program and the Artemis program is really the focus on sustainability and using the moon as an outpost for further exploration.
This time, we're going back to learn how to live and work on the moon.
The Space Launch System really is the culmination of our knowledge for 60 years of building rockets.
We started by looking at over 1,700 different potential components that would go into the rocket, and by looking at the way we could reuse some of the most reliable equipment that was flown on the shuttle.
We took those and we put them together into a system that had enough energy to make sense to do the mission that we've been asked to do.
We're moving from low Earth orbit, like you see in the International Space Station today, to moving beyond that, to taking the next step in exploration.
It's 322 feet tall. It's got 700,000 gallons of cryogenic propellant in the core stage alone. It can produce 8.8 million pounds of vacuum thrust. The Space Launch System is really a national rocket, a national asset too.
We have worked with contractors as well as with our NASA experts, our science and engineering department, our safety and mission assurance team.
To get the Space Launch System designed, developed, and produced, it has taken thousands of companies across the country.
It comes together by train, it comes together by plane, it comes together by barges.
So all of that culminates at the Kennedy Space Center for the launch of the first Artemis mission.
Everybody has worked together to ensure that we have a safe and reliable rocket.
At NASA, safety and testing is extremely important because ultimately this rocket isn't meant just to carry cargo, it's meant to carry people.
It takes all types of education, all types of backgrounds, all types of diversity to do the things we do, and it'll be great to see a diverse crew land on the moon.
Where the Space Launch System comes in is providing that reliable transportation so that we can start flying these rockets on a routine basis to take people and to take payload to that outpost, the moon, and also the gateway system.
We have a generation who've never seen deep space exploration, and this will give them an opportunity to see that this is something that they can potentially do themselves.
It's going to be a paradigm shift for NASA. We're going to be back to looking at things that nobody's ever done before.
A lot to look forward to, and it all begins with launch. Afterwards, our friends at Johnson Space Center in Houston will control Orion once it's on its way to the moon. Let's get an update of operations there with NASA's Leah Cheshire.
Thanks, Megan, and welcome to Mission Control Houston, home of the red, white, and blue flight control rooms. Today, we're in the white flight control room, which is just across the hall from where you usually see us in the International Space Station flight control room, like this morning when we conducted a spacewalk outside the space station. Now, this white flight control room has been used before during some space station missions, plus commanding Boeing's Starliner. Previously, this room was used for space shuttle missions and was renovated in 2014 to support our use with the Artemis program. Today's flight director is Judd Freeling, a flight director of 11 years who will lead the team through the ascent portion of the mission. After Freeling's shift today, flight director Rick LeBrode will lead the team through the rest of the mission all the way to entry and splashdown when Freeling will step in again. Other console members will be monitoring the various systems on Orion, like propulsion, solar arrays, and trajectory, and they arrived on console about 5 hours ago. And you might also be surprised to learn that there is indeed a Capcom, or capsule communicator, on console today as well. While there are no crew on board, Jay Marshke and other capsule communicators will be training throughout the mission in preparation for Artemis II and beyond. The Capcom is the single person in the room who speaks with the crew, gathering info from mission control team and keeping streamlined communication with the astronauts in space. We're counting down to liftoff when teams here will really jump into action and monitor the first Artemis flight, sending Orion further than any crew-rated spacecraft has gone before. But for now, Megan and Kayla will send it back to you at Kennedy Space Center to keep walking us through the events of the day.
Well, you just heard Leah remind us that no one is inside Orion today. Again, it's because Artemis I is a flight test to prove we can safely return crew from lunar orbit on Artemis II. And when we launch the first crewed mission, NASA has a very diverse and talented core to choose from, including Kayla here. We're looking at video now of some of your friends who got to go to the pad. That looks fun.
Yeah, it's always so exciting to see the rocket on the pad because you know you're getting close to launch. So we're all just really excited to see how this test goes today.
I wish I could have gone out there with them. You and me, what happened? We didn't get our invite. And I thought this was fun too. Some of your friends also got to fly over the pad in T-38s. Here's video of that now, incredible video. So these flyovers were common during shuttle, right?
Yeah, and we still try to do them whenever we can. We actually use the T-38 jet as a training platform. It's a chance for us to practice making real-world decisions in a high-risk environment, practice working as a team, and a good analog for spaceflight.
Okay.
But we also like to fly by the pad when we can, when we have a rocket out there. It's a way of saluting and thanking the team for all the work it took to get to this moment.
That's great. Yeah, a worthwhile thing to do because, yes, the team has worked so hard to get to this moment. And you spoke about training. Has training already started for Artemis II for you guys?
We've been developing the training, but the crews aren't assigned yet, so they're not in dedicated training flows yet. But our team at Johnson Space Center, where we train for human spaceflight, are working on all of the things that we're going to need to teach the crew and the best ways to go about that. Once we get that crew assigned, they'll be straight into training right up until launch day.
Awesome. Cool. All right, I can't wait to hear who gets assigned. And the absence of crew today doesn't mean Orion is empty. There are plenty of other interesting things flying on Artemis I, including several technology demonstrations and science investigations we're going to show you throughout the broadcast. There are also some mementos like these seeds that we have right here, right, Kayla?
Yeah, we have an example of the moon seeds that will be flying as part of this mission today. And the idea actually comes from an Apollo 14 astronaut, Stuart Roosa, who flew seeds with him to the moon, hundreds of them, and then brought them back to Earth. And then they were planted all over the country and the world, and they're called moon trees. And so we're kind of carrying on with that idea on Orion for this launch.
Yeah, I love that. And the seeds that are flying on Artemis I, it's going to come back and they're going to distribute it to a number of organizations through NASA's STEM program. So it's really a neat idea. And so these moon seeds are part of what's inside Artemis I's official flight kit, along with more than 10,000 other mementos, like this Apollo 8 commemorative medal you see here, a nod to 1968 when humans first orbited the moon, and a bolt from Apollo 11, 1969, when humans first landed on the moon. Those items are on loan to us from the National Air and Space Museum, and once back on Earth, will be exhibited there, so you can check them out. There are also a variety of flags, pins, and patches like these Artemis I patches that will be distributed to people who contributed to this flight. Now, NASA spacecraft, both crewed and uncrewed, have carried mementos like these since the 1960s. Astronauts are also allowed their own personal flight kits. So I was wondering, what did you bring with you for your Crew 3 mission?
I actually brought a couple of examples to show you. The moon seeds inspired me to share that I actually brought some vegetable seeds with me. So these are kind of fun. They're dragon themed. So I got dragon carrots and dragon beans since I went up on a SpaceX Crew Dragon vehicle.
Sure.
And then of course, I think the most important, meaningful thing to all of us is usually pictures of our family and friends. So have like a picture
family.
of me and my family at my sister's wedding. Friends backpacking in Alberta, Canada, and then my in-laws.
Right side up.
together on a family vacation. And I also brought some flags, some American flags, and then United States Navy flags, since I'm a naval officer. So things like that, I think it's just so human to want to bring stuff with you, right? Souvenirs, who doesn't love that?
Yeah, absolutely.
But I think for most of us, pictures of our family and friends, things that connect us back home, are the most important.
Yeah, 6 months might not sound like a long time for people, but it is, right? Wouldn't you say? And you're also so far, it's nice to have those tangible things that remind you of home.
Absolutely. Yeah, really important for us.
Cool. Thank you for bringing those. It was really fun to look at. All right, 1 hour, 27 minutes and counting until launch. And we have our first questions from social media. So let's take a look at the clip here. Kayla, you're going to notice a familiar, handsome face.
Hey there, I'm Chris Evans, and I play Buzz Lightyear in Pixar's Lightyear movie. I was wondering, when we fly future Artemis missions with astronauts, how many people can fly on board the Orion capsule at once?
My nephew's probably asleep, but he's a big Buzz Lightyear fan, so he's probably going to enjoy watching that question tomorrow. But we can get 4 astronauts in the Orion space capsule. It's a little bit bigger than the Apollo capsule, about 30% more habitable volume. And so instead of supporting 3 crew for about 2 weeks, Orion can support 4 crew for about 21 days.
Okay, good first question. Let's take a second question now. Can a microbiologist be an astronaut?
Absolutely. And we already have microbiologists who are astronauts, like my training classmate, Zena Cardman. We hire people from all sorts of different backgrounds. All you have to do is have a STEM degree. Beyond that, you can come from any pathway. So some of us are military astronauts like me, either aviation or I'm a submariner, but we have a ton of people from different scientific and engineering communities, including microbiologists.
Yeah, I love that it's so diverse, because I think diversity really adds to what you guys can do.
Yeah, and those unique perspectives, I think, make us stronger as a team whenever we're tackling a new problem. Having people with different, not only academic backgrounds, but all of these scientists, a lot of them have different field experience. So like Zena worked in some really extreme environments in Antarctica, in caves, doing a lot of her research. So it's not that different than what we're hoping to do at the South Pole of the moon. So these perspectives are really important for us to form the best team that we can.
Yeah, that's interesting. All right, I think we have time for one more question, so why don't we pull one up? What is the coolest part about Artemis to you?
I mean, I think I can't even quite get my head around how it might feel for the crew to orbit the moon on Artemis II and see it up close. And then, of course, on Artemis III to actually land on the moon and conduct a moonwalk. It's just going to be incredible to have that view back of our home planet. And so just the thought of sending human beings back to the moon, it's just super exciting for all of us.
I honestly didn't know how you're going to answer that, because there is so many things to look forward to pinpoint, the thing that you're most excited about. I thought that was going to be a hard question, actually. All right, so great questions. Keep them coming using #Artemis wherever you're watching this broadcast, and keep sending those moon-inspired content too. Again, that's #NASA MoonSnap, and we're going to show some of them later in the broadcast. Okay, 1 hour, 24 minutes and counting until hopefully liftoff of Artemis I, and it's time for another update with NASA's Daryl Nail, who's with the launch team as they were monitoring a leak.
Yeah, that's right, Megan. We're inside the firing room number 1 here at the Launch Control Center at the Kennedy Space Center. And currently we have an update on that red crew, which went out to the pad to torque down some bolts on a leaky hydrogen replenish valve for the core stage. And that update is that the red crew has departed the blast danger area. They have completed their work. They got the go at 10 p.m. this evening, 10 p.m. Eastern Time, to go out and conduct work that took roughly an hour from the time they were given the go till the time they left the blast danger area. The technicians, 2 technicians and 1 safety representative, did the work out at the pad on the replenish valve. And now that they are on their way back, the team is now examining the work and whether or not that leak is still there. What we do know is, you may have heard me mention that this put the liquid hydrogen tank into stop flow, and as a result also stopped a required 90-minute engine bleed for the liquid hydrogen side. Teams have come to the conclusion that only a 45-minute bleed is required at this point. They can resume the bleed at the point that they left off, and it'll be enough to meet that requirement for launch. You're looking now at a graphic where we're tracking the core stage fill rate. We did this earlier this evening. Took about 4 hours and 20 minutes to fill the core stage. You can see on the left that the core stage liquid oxygen is at 100%. That's the same for the upper stage, and both are in stable replenish. As you can look to the right, though, you can see that we're at 97% for liquid hydrogen. The reason for that is because when we went into stop flow, that means that the replenish was no longer refilling the tank, and that liquid hydrogen was boiling off and draining some of the capacity out of that particular tank. So we've lost some liquid hydrogen. The plan is to resume, of course, the filling of liquid hydrogen, which goes into that into the liquid hydrogen tank on the core stage and then vents out on that flare stack that you see to the right, where excess hydrogen is burned off. That's the latest here from Fire Room 1. Megan, we'll send it back to you.
Thank you, Daryl. All right, let's go back inside our Apollo Saturn V Center now with NASA's Dan Hewitt. We last sent humans to the moon using the rocket behind you. Can you show us how we're going back now with Artemis?
Absolutely. Thanks, Megan. So Artemis I is going to take us from planet Earth around the moon and all the way back, and I'm going to show you every step of the way. Like every great space mission, it starts with a launch. In this case, 4 RS-25 engines, 2 solid rocket boosters ignite, sending SLS and Orion into the sky. On the way uphill, we'll have a number of jettison events, things coming off the rocket. One of the most visible, these 2 large solid rocket boosters a little over 2 minutes into flight will break away. We'll also have the launch abort system come off once we're high enough, and then 3 fairings, which are protecting Orion's capsule and service module during the flight through the thicker parts of the atmosphere. Now, after the core stage has consumed its propellants, we'll hear MECO, main engine cutoff. Those 4 engines will cut off. The core stage will drop away, handing over propulsion duties to this, the interim cryogenic propulsion stage. Its first job is a perigee raise maneuver. Perigee just means the lowest point of your orbit. This will give us a nice circular path for Orion around our planet. While it's there, we can really check the spacecraft out, make sure everything from electrical systems, guidance, navigation, and control, communications are all functioning before we commit it to heading to the moon. And we do that with this, the translunar injection. This will be about an 18-minute firing on today's timeline, and this is done to give us enough energy to get out of low Earth orbit and make our way to the moon. Shortly after that, the ICPS will separate. It'll do a disposal burn, sending it around the moon and into an orbit around the sun. But from there on out, propulsion duties get handed over to the European service module. It's going to make a couple of outbound trajectory correction burns on the way out, critically testing that orbital maneuvering system engine, that large one on the very bottom that's going to be needed when we start making our maneuvers around the moon to get into what's known as distant retrograde orbit, or DRO. To do that, we're going to do the outbound powered flyby, dipping in about 70 or 80 miles off the lunar surface, really pushing with that large engine. That's going to slingshot us around. We're going to do a final orbit insertion maneuver, and then we will be in DRO, distant retrograde orbit, this dotted line right here. Distant, we're about 40,000 miles off the lunar surface, and retrograde, because the moon orbits the Earth in a counterclockwise fashion, we're going to be going clockwise, opposite retrograde. It's a very stable orbit, doesn't require a lot of energy to maintain your space there, really lets us put Orion through the paces, learn about using this spacecraft in deep space. But eventually it'll be time to come home. We'll fire up the engines once more, do a departure burn. This is what commits us from departing the moon and heading back home. We'll dip in close to the surface once more for the return-powered flyby and execute correction burns on the return transit as we target a splashdown in the Pacific Ocean. Before that happens, the spacecraft separate. The European service module's job is done. It drops away to burn up, revealing the heat shield. This is goal number 1 for this flight, is testing that heat shield at lunar return velocities, because when we hit the upper atmosphere, we're going to be moving more than 20,000 miles an hour, heating that up to more than 5,000 degrees Fahrenheit. So really need to make sure that that can withstand that heat of reentry. After it makes it through, parachutes deploy, Orion splashes down in the Pacific. A Navy ship and other recovery assets are standing by to pick it up out of the water and bring an end to the first mission in the Artemis program. So that's all still going to unfold. It all starts with launch today, though, so let's get back to the countdown. Over to you, Megan.
Our return to the moon would not be possible without our partners across the country and the world. So joining us now is Frank Davina, head of ESA's European Astronaut Center. Good evening to you.
Good evening.
Well, so I want to ask you, talk to me about Airbus and how that company and ESA contributed to the Orion spacecraft.
Well, Airbus is, of course, the lead manufacturer and integrator of the service module of our Orion capsule, and that will fly to the moon. So this is a very important part, of course, because without the service module, it's clear that we would not get to the moon or would not be able to return from it. So it's a very important partner for ESA, but there are industries across Europe, not only Airbus, but across Europe, that are contributing to the service module in Italy, in France, Belgium. Really, it's a really European project.
Yeah.
Frank, we've been close partners, NASA and the European Space Agency, for decades now, and partnering on things like the space station, scientific exploration, and of course commercial crew missions. Matthias Maurer, ESA astronaut extraordinaire, was on my crew, Crew 3. Can you tell us a little bit more about what makes these partnerships so important?
Well, it's important, these partnerships, because we want to do sustainable exploration of the moon. We want to explore space on a sustainable way. And I think partnerships in that sense are essential. One nation alone, could they do it? The US maybe, yes. Europe certainly could not participate to a lunar program by themselves or could not do it by themselves. But I think if we do it as a partnership, we can go a lot further, we can do a lot more. We can leverage technologies, we can leverage talent in all these countries across the globe that can really push the partnership forward.
So looking ahead to future Artemis missions, we're going to have ESA astronauts on board those. Have you guys begun preparing for that training, anything like that?
We have actually started preparing already for lunar missions, surface missions. We have a program called Pangea in ESA, which is basically, there are NASA astronauts participating in those trainings. Stephanie was just over with us just 1 week ago, doing field trips, and we are actually starting to prepare to see also which technologies do we need to use that we can, at the best possible way, do science on the moon, because of course we just do not go there to walk around or do two things. We want to do real science, we want to do discoveries, we want to live there for a sustainable way. So which technologies do we need? And that we are actually starting already in the European Astronaut Center. We actually started already more than 5 years ago developing this training program. So yes, we are involved again together with our NASA colleagues and colleagues from the international partners to start preparing crew to really do sustainable surface exploration of the moon.
Yeah. And you guys are doing more than just crew, right? You guys are contributing to the Artemis programs in other ways?
We are contributing to the Artemis program in many ways. Of course, the service module that we will see launching here hopefully today is the biggest part today. But we are looking into a lot of other capabilities. First of all, there is the gateway. That will be a real element to enable the sustainable exploration of the moon. We have the communication system on the gateway. We have the IHAP, the habitation module. We have Esprit, which is a refueling module, which is essential if you want to sustain the gateway there for a longer period of time. Of course, you need to be able to refuel the system. So these are essential elements, again, that ESA is providing. We're also providing small technology experiments. Radiation, for example, will be very important. We are looking in crew exercise device for the gateway. We are looking into medical systems. So these are also small components, but for the crew that are very important because we need to keep the crew healthy there, of course.
You're a great partner. You have so much that you're contributing. We really appreciate it.
We have a lot that we can contribute. And,
Thank you.
And of course, in this ministerial, because we have now our ministerial conference coming up next week, where the big decisions are going to be made for the next decade. And there we will propose a European lander that will bring logistics to the moon. And this logistics capability that will be a big part of the integrated Artemis program will allow us to have European astronauts actually walking on the moon. So that is really interesting for us.
Wow, Frank, thank you so much. And we continue to look forward to the contributions that we can make together with this partnership. Thank you so much.
Thank you for having me. and good morning to the viewers in Europe.
Thank you so much. All right, and speaking of viewers, we have a ton of people out here on along the space coast of Florida watching today's launch. So let's head on over to NASA's Leah Martin. She's over at the Visitor Center with a whole bunch of excited people.
Oh my goodness, Megan. You know, this normally is a time of night that people are winding down and getting ready for bed, but there is not a single person here who has sleep on their mind. Everybody is so excited, on the edge of their seat, trading stories, talking about previous launches and being excited for this one. And I'm actually joined here by 3 women who are thrilled to come out and watch tonight's launch. What does it mean to be out here and see this historic launch tonight?
It's an amazing moment. I grew up on the Space Coast watching launches, and so to be out here tonight, it's incredible. It's an amazing feeling to be out with all of these people celebrating, and we're super excited to be here.
And Isabel, I know that you said that you have been having your eyes on this launch. You've been watching on the previous attempts. What does it mean for you to be here tonight?
Well, yeah, this is our 3rd attempt here. We were here for the 1st and 2nd here at Banana Creek, so we're really excited. The energy out here is electrifying, and we can't wait to see this thing go off.
Now, this is the first of a series of missions that are becoming increasingly more complex. What are you most excited about for the Artemis missions?
Leah, I am so excited to be here. I just feel so honored because, as you know, this isn't just a momentous launch for humanity as a whole. It's so important for gender and cultural minorities across the globe because Artemis is landing the first woman and the first person of color on the surface of the moon. This is this generation's Apollo. And so all of the people who didn't have the opportunity to live through Apollo and be inspired by that have the opportunity today to witness it. And I'm just so grateful to be here. I can't wait to see the positive impact.
One more question. This is going to be something that you guys, I'm sure, will remember for your entire lives. How are you marking this? Do you have any special plans of capturing these memories and being able to pass them on to, people in your life?
Well, my son is growing up here. I didn't grow up here, and so he's going to grow up here on the Space Coast, and I just can't wait for him to just grow up with the Artemis missions.
Well, Megan, we're out here. We have our eye to the sky, and we can't wait to see it go. Back to you.
Really great interviews, and wow, I saw that drone shot that we had showing all of the bleachers filled with people there to watch the launch. That was incredible. If you're just joining us, welcome to NASA's live launch coverage of Artemis I, our return to the moon in almost 50 years. I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron, who flew on NASA's SpaceX Crew 3 mission and returned home earlier this year after living and working on the International Space Station for about 6 months. I gotta ask you, how was that experience?
It was incredible. We had such an amazing time up there. The Expedition 66 crew was awesome. I've been saying since I got back that we're the happiest crew in the history of the space station, and nobody's been able to really challenge me on that yet.
You guys look very happy in that photo.
Oh man, we were just like a family up there executing an incredible mission. Some amazing science experiments. We got to do 3 spacewalks. It was just, you couldn't have planned a perfect first mission for me, Matthias, and Raja, and of course our veterans up there, Mark and Tom. It was amazing. We had an incredible time.
Yeah. Wow, look at that photo of you in the cupola. That is amazing.
Yeah, the views are beautiful. It's just like every time you look out the window, it takes your breath away.
Wow. And now here you are, adding some valuable insight into Artemis I. This is our 3rd opportunity to launch NASA's brand new Space Launch System rocket and Orion spacecraft. This is an uncrewed flight test to pave the way for future crewed missions, starting with Artemis II. And Kayla, you could be chosen to fly on some of those future missions. How does that make you feel?
Honestly, it's a little unbelievable to me. I could barely imagine what it'd be like to go to the space station until I did it. And just thinking about what it would be like to look back at the Earth from orbit around the moon or even standing on the moon kind of blows my mind.
Wow.
So yeah, it's hard to even imagine that that's true, but it's a really special time to be at NASA and an even more special time to be in the astronaut office.
Yeah, that's a beautiful picture of you seeing the moon, right?
Yeah, that's sort of a moon spotting adventure there. I've got binoculars. One thing that's really cool about seeing stars and the moon from orbit is you're not looking at them through the atmosphere. So you get these very clear views. Oh. And the moon is always super spherical. You never get these sort of slices that look kind of flat from Earth. Up there, you see it in 3D, it feels like.
Wow.
So yeah, I think we all sort of fall in love with the moon from space in a whole new way.
Yeah. Well, today's launch attempt comes amid a very busy year for us at NASA. Some of the highlights include 2 more commercial crew launches with SpaceX, Crew 4 in April, you're seeing there, and Crew 5 last month. In May, NASA and Boeing flew OFT-2, the second uncrewed flight test of the Starliner capsule. The goal is to certify the capsule for regular flights to the International Space Station after a crewed flight test next year. In July, we released the first images captured by our James Webb Space Telescope, and wow, they are magnificent. Pictures like these could help us answer some of astronomy's biggest questions about how our universe began. And then in September, we intentionally slammed the DART spacecraft into asteroid Dimorphos and successfully changed its course. The asteroid wasn't headed for Earth, that's important to say, but the test was to show that we could defend our planet if needed.